Section 12.3, Measures of Dispersion. Example 1, find the mean and median for the following data sets A and B. If we look at data set A, our values are 5, 6, 7, 8, and 9. Go ahead and find the mean. 7. And our data set B is 1, 2, 7, 12, 13. Take a minute to find the mean. Pause the video. And our mean is 7. Set A, our median is 7. And our median for set B is 7. Look at those data sets. They have the same mean and the same median, but they are very different data sets. Data values in A are much closer to the mean and the median than those in B. We need more than the mean or median to describe these two data sets. So we talk about measures of dispersion. Dispersion means spread. Measures of dispersion tell us how spread out the data is. One measure of dispersion is range. Range is the greatest value in the set minus the smallest value in the set. Example 2, find the range of the data sets A and B in example 1. Here are our data sets A and B again. Our range for set A, 9 minus 5, our range is 4. Set B, our range of set B, 13 minus 1, the range is 12. Again, same median, same mean, very different ranges for our sets. Sample variance, S squared, is the measure of how far each value in the data set is from the sample mean. We find the deviation of each data point from the mean by subtracting the data point minus the mean. We end up with negative deviation values for the data points that are less than the mean. That is why we square the values when finding the sample variance. Our formula for the sample variance, S squared equals the sum of the differences squared divided by n minus 1, our number of items in the set minus 1. Example 3, find the sample variance of the ages in the left-hand column below. So we have the ages of 32, 41, 47, 53, and 57. Before we can find the deviation, we need to find the mean. The mean is 46. Go ahead and pause the video and compute the deviations. -14, -5, 1, 7, 11. Go ahead and square the deviations. 196, 25, 1, 49, 121. Now to find the sample variance, S squared, we need to sum our deviations squared. So you're going to add up 196, 25, 1, 49, and 151. And then divide by 4. There are 5 data points, but we divide by n minus 1, so make sure you divide by 4. Equals 98. Sample standard deviation, S, is a measure of the spread of the data based on how far each data point is from the mean. Recall squaring the deviations to find the sample variance. Finding the sample standard deviation is taking the square root of the sample variance. Standard deviation S equals the square root of the sum of the deviation squared divided by the number of points in the data set minus 1. Example 4, find the sample standard deviation of the ages in example 3. We had our S squared to be 98. Standard deviation is the square root of the sample variance. Square root of 98 equals 9.899. Calculate the standard deviation. We've got our data values 9, 18, 22, 27, 29, 32, 40. The first thing we need to do is find the mean. Pause and compute the mean. The mean equals 25.28. Once we have the mean, we can now find our deviations. Negative 16.28, negative 7.28, negative 3.28, 1.72, 3.72, 6.72, 14.72. And now square those deviations. 265.04, 52.99, 10.76, 2.96, 13.84, 45.16, and 216.68. Sum the deviation squared. 1, 2, 3, 4, 5, 6, 7 items we're adding together, and then we're going to divide by 6. Our S squared is 101.24. S equals the square root of 101.24, which is 10.06. Standard deviation of a frequency distribution. This is example 8, and we're going to find the standard deviation of the values. We're given a frequency distribution instead of a list of values. So if we look, the data value is 2, and the frequency, that 2 happens 5 times. The 3 happens 8 times, the 4 happens 10 times, and the 5 happens 2 times. If we add up the frequencies, we find that our total number of data points is 25. X times F tells us our total of the 2's, which is 10. 3 times 8 is 24. 4 times 10 is 40. 5 times 2 is 10. Our total is 84. Now we're going to find our mean. We're going to do that 84 divided by 25 to find our mean, which is 3.36. And now we can find our deviations. Make sure you're subtracting the data value minus the mean. Negative 1.36, negative 0.36, 0.64, 1.64, 0. Our deviations always sum to 0. Go ahead and square those deviations. 1.849, 0.129, 0.409, 2.689. The sum is 5.076. And now our deviation happened 5 times for the 2's. So we need to multiply our deviation squared times our frequency. 9.248, 1.036, 4.096, 5.379 for a sum of 19.759. Our standard deviation is the square root of the sum of the deviations times the frequency divided by n minus 1. The sum of our deviations times our frequencies is 19.759 divided by 24. There are 24 data points. 19.759 divided by 24, the square root of 0.8232, which is 0.91. Section 12.3.